So on your page, that should look like this. On your page, on your board. 5 times 3, everybody?
15.
Put the 5 and carry the 1. 5 times 7 is 35 plus 1 is 36. Put that 0. We're done with that 5. 4 times 3 is 12. Put the 2. Carry the 1. 4 times 7 is 28 plus 1 more is 29. So your top row would have been 365. Your second row, 2,920. And then when you add them up, 3,285. Okay. All right, we're going to jump over the division one today, just because we got a little bit of a late start. What do you think you're doing with those two fractions right there? When you see it set up like that with that bubble, or sometimes it's just a big space in between them, Faith, what are we doing? We're comparing them. Which one is larger? This is where we know all those methods. Our heart method, our steal it and hide it method. Changing one of the fractions so it has the same denominator as the other. Okay. Sometimes we've even done reasoning. But use one of those methods right now to solve, to compare those two. How many of you did the heart method or are working on the heart method right now? Okay. How many of you did steal it and hide it or are working on that right now? Okay. Anybody change the denominator? Can you change the 16 into an 8? You can by dividing, but you can't divide that by the same number. Not that 9. Can you multiply to get from 8 to 16? Yeah, so I could have just changed one side of this and made an equal fraction, an equivalent fraction. I could have changed that to 8/16. And then this is still 9/16, but now they have the same denominator, and it's real easy to see which one's larger. If all the pieces are the same size, they're all 16ths, then if I have more of them, then I have more. So 9/16 is bigger. Did anybody use a different method besides all that? Yeah.
I use reasoning.
Okay.
Half of 16 is 8, and 9 is over 8, and half of 8 is 4. So
Okay.
that's just half, but 9/16 is 1 over half.
This fraction is equal to 1/2. This fraction is a little bit over 1/2 because 8/16 would have been half. So you could have reasoned it that way. You could have drawn a number line and tried to put those on there. Some of these methods are just a little longer than others. Okay. But I did see a lot of different thinking going on. A lot of different thinking, all getting you to the same answer. Okay. All right, good. All right. When we left, I'm going to switch to this just to make this a little, not to reading, but
You have to make it smaller.
Huh. But why do some do that and some don't? And that's what we did during Inspire the last day we were here.
What?
Okay. When we were here, I'm going to put this one up on the board because this will carry us right into what we're doing today. Before we left, we had problems like this right here. All right, there might have been one like that. All right, tell me what to do here. What do we need to do to solve this? Yeah. Okay. This fraction piece is big enough to take that away from it, isn't it? So I just carry that. Remember how we just brought that? If I don't have to bother that whole number, just bring it over. If I can just, if these are small enough right here to subtract from one another, and if I have 4, then I can take 3 away from it, and I would have 1/5 left. So my whole answer is 4 1/5. And so remember how we said pause and stop and look, because if you can see right away, oh, I don't have to do much there, I can just subtract that, then you can just, that's super fast. Okay. What if we had this same mixed number, 4 4/5, but what if I needed to subtract 6/5? Okay, so we saw both types of problems. Reagan, what would you do?
You would make the mixed number into an improper fraction.
Okay. All right, so we would start off with using MAD and changing this to an improper fraction. And that would be, I feel like I'm in the way here, 5 times 4 is 20 plus 4 more would be 24. 24/5. This is just another name for this. It's just its other form, okay? So 24/5 minus 6/5. Now I have plenty of fifths, so I can subtract. I just have to take 6 away from 24. Okay? Now if I can't do that in my head, just come over to the side. 24 minus 6. And we got 18. 18/5 is our answer. Okay, so that's what we were doing our last day here. All right, so let me give you a problem similar to that, and then we'll take the next step. So we're just adding a little bit to it today. Okay, let me give you a minute to try this, because we were getting really good at it when we had left, or right before we had left. And then we had snow cat. What did Mr. Kelsey say? Snowcation. Snow vacation. Take a pause at first. You know, can I do this in a quick way, or am I going to need to use MAD and change it to a mixed number first? Remember, when you use this, there's 3 parts to it. I'm going to multiply these 2 numbers. I'm going to add the numerator in. Don't forget that part. And then I'm going to put that number that I get on top of 8 as the denominator. What does this become? I'm going to go ahead and jump in here so you can check yourself. When I use MAD, what does 7 and 5/8 become? Yeah. 61/8, says Martin. Will you agree with that? No? Yes? Okay. 8 times 7 is 56, but you've got to add that 5 because you've still got 5 more. So 5 and 56 is 61/8. Yep. Minus 7/8. Now, I'm not good enough to do that in my head. I guess I could if I sat there long enough. But I'm just going to come over here and subtract 7 from 61. Okay. Alright, so we got 54/8. How many of you have that sitting as your answer right now? 54/8. How many of you changed that to the right form it's supposed to be in? Did anybody change it back to a mixed number? Okay, that's what you've got to do. We can't leave this here. So this is where, remember, we used a number bond to change it back. How many groups of 8 can we pull out of there? What's the most 8 8s we can pull out? Yeah. 6. Okay. 6 times 8 is 48. 6 times 7 is 56. It's a little too big. So, what did you just tell me? 6 times, which would be 48. How many are left over? 6 8s. So we've got 6 and 6 8. Okay, as our final answer. All right. What's it going to look like today? Well, so today, this is what we're going to see. Before, it's just been a mixed number, and then you subtract a fraction from it. Today, we're just subtracting a mixed number from a mixed number. Okay? So we're trying to see subtraction in all kinds of ways with fractions. What do we do when there's 2 whole numbers and 2 fractions? What do you think? Well, we're not going to add them together, just we're subtracting. Okay? Huh? Okay? Isabel says we're going to subtract them, and we are. We're going to look at the whole numbers first, and then we're going to look at the fractions. Okay? Again, there's a super quick way with some of these problems, and then there's the way that's going to take just a little bit longer. What do you think?
You have to subtract 2 from 4.
Okay, we're going to subtract the whole numbers first. But, you know what? This is where you've got to really pause. If you see at first, oh, I can subtract my fractions really easy because this one's larger than this one, then I'm going to jump to my whole numbers and then do my fractions and be done. Can I take 2 away from 4? Yeah. And I'm going to get 2. Subtracted this and this. Can I subtract 1/8 from 4/8? Yeah, what will I get? 3/8. Okay, and so I'm done. I don't even have to do a number bond. It's already a mixed number.
I feel like we've done this before.
We might have. Well, we did it with addition.
Yeah,
You might have seen a problem like that somewhere. I'm thinking where you probably have seen it in iReady or something like that, not in our book. But we did add these. It's almost the same thing. Okay. If you notice that you can just subtract these 2 right here and get it, and then you can subtract the fraction pieces and get this. Then do it the quick way, just like that. Subtract your whole numbers, subtract your fraction. Okay, let's try one like that. Let's go with, put this one on your board. Fraction piece on the left is big enough to subtract my fraction piece on the right, then go ahead and do the whole numbers and then the fraction. This kind of problem is very quick, isn't it? Okay, what would I get? Okay, 5 take away 3 is 2. You're right, and then what? And 4/12, yes. She got 4/12 because 8/12 take away 4/12 is 4/12. And that's as easy as it gets just about with those types of problems. Until you have one that's not like this.
Yeah, I was thinking in my head, how would you do it?
Well, what if we had 5 and let's kind of reverse this a little bit. Now you might immediately jump in and go, oh, 5 take away 3 is 2, and then 5 take away 8 is, Okay, if that happens, back up. You need to kind of start again. Because Will, what do you think we're going to do to solve this?
I think you make 5 and 5/12 into an improper fraction and 3, and 8/12 into an improper fraction, and then subtract them, and then come back and put in this number.
Okay, so is that several steps? Yes, but that's exactly what we do. And it's like what we've been doing, and so we've already had lots of practice with this. What do you want to say?
I have another one. You can take away 1 whole from 5 and add it to the 5/12.
You absolutely can. I'm going to tell you, in years past, that's how I taught it. I will say, because it's not what we've been doing a lot of, it has been a little confusing for some. But if you want to do it that way, you absolutely can. Okay. Now let me explain what they just said. Will's way was, hey, I'm going to change this with MAD, and I'm going to change this with MAD because, hey, we're good at that now. We've been doing that. We've had lots of practice. Once I change both of these, then I can subtract and then change my answer back into a mixed number. So let's do that real quick, and then I'm going to show you what Mason said. 12 times 5. Oh, it's the 12s. Okay. What's 12 times 5? 60. Plus 5 more would be 65/12. What's 12 times 3? Come on, somebody knows their 12s. Yeah. 36. Plus 8 more. Okay, and 44/12. Now, do y'all know how to do 65 minus 44? What?
Yes. Yeah. Not in our heads.
Not in our heads, for sure.
No, not in our heads.
Not in our heads, and
Not on our fingers.
I'm not expecting you to do it on your head or in your finger, or
I know the
in your head or on your fingers. Not anyway.
I think I know the answer.
Now, once you put it like that, you may easily be able to see that it's 21. But are we going to leave it as 21/12? No, we're going to change it back to a number bond. How many times can we pull a 12/12 out of there? Just one. Because 2 12s is 24. So 12/12 and, is it 9? No. Yeah.
9.
Okay. And then 9/12. So 1 and 9/12 is is our final answer. Okay? Alright, I'm going to erase this and just show you real quick what Mason was talking about, and then we'll do some practicing together. Okay, the way that Mason said you would not be doing MAD, and if you don't like doing MAD, you might be like, yes, but I'm going to tell you MAD is the simplest way to do this. Okay, it's the least confusing way to do this. And I know that because of years of doing this and watching folks kind of have trouble with this. All right, what Mason was saying, hey, is if we just borrow 1 from that 5 and open it up and put it here, we know every whole number is a number over itself, right? So if I borrow 1 from this 5 and change it into a 4, I'm giving 12 twelfths right here, but I've got to add them together. 12 twelfths and 5 twelfths is what? 17 twelfths. Now, I don't know if you realize what I just did. I just changed this guy's name. I took 1 whole and made it into twelfths, and I put it with this, so I'd have all my twelfths. Now, is it easier to subtract? If I write it correctly, it'd be easier. Yeah, 4 take away 3 is 1. 17 twelfths take away 8 twelfths would be, and didn't we just get 1 and 9 twelfths with our number bond a second ago? Okay. For some of you, you may see that and go, oh, I like that. That's easier to me. You know, everybody's different. You definitely can do it this way. But because we've done MAD so much, I think that's probably the simplest way for most of us. Because we're just used to that. Okay. Any questions about this way, or I'm not going to keep showing this way every time I do a problem, but I just want you to know it's there. Yeah.
What if, like, you gave a whole to 5 twelfths, but 8 twelfths was like improper fraction, and
Like it wasn't big enough.
yeah,
Okay.
could you just give it 3?
You could give it as many as you needed to, and think about it. When we do MAD, we're giving it all. You know what I'm saying? We're turning that whole 5 into 12. Okay. But usually you're not going to see this with an improper fraction inside of it. Does that make sense? We did a couple times, I think, back before the snow, but it was just because we weren't to our final answer yet. We had to change it, you know. I don't think you're going to hardly ever see that, though. Okay. But yeah, if you needed to borrow more than 1 from here, you certainly could. Okay. Good question. Good thinking. Especially on a Tuesday after we went out. Okay, let's do a few practice problems so we get comfortable with this, and then we're ready to move on. Let's see. All right, everybody, on your board. 5 and 3/8 minus 2 and 5/8. Okay. So what's your very first step here? Yeah.
8 times 5.
8 times. Okay, I see what you're doing. MAD. Okay. Before you even do MAD, though, what do you need to pause and look for? Yeah.
To see if 5 and 3/8 is, you can subtract that easily.
Because sometimes we jump right into MAD and we do all this work and we didn't have to, you know. But if you probably already noticed it without even having to pause. This is larger, so I'm going to need more than 3/8 to subtract there. So Caleb's exactly right. Our first step would be to do MAD. We're going to multiply right here, and then we're going to add 3 to that. So what is our new fraction? When that becomes a mixed number, what's our new fraction going to be? Brandon, what does that turn into?
The 5 would turn into a 40.
Uh-huh.
Plus 3 would be 43.
Good. 43/8. Now, what do I need to do over here? Just to make the subtraction simpler, what do I need to do to this fraction, Mason? Okay, we're also going to do mad right here. 8 times 2 is 16 plus 5 more, 21. This becomes 21/8 with mad. Now we're going to really do some subtraction. Yeah. Okay. Hold on to your answer. Final answer. What is it, Ishmael? 22/8. But are we finished? Nope. Need a number bond there. It's all coming back to you now, isn't it? What's our final answer going to be? How many groups of 8/8 can we pull out of 22/8? Caleb, what's it going to be?
2 and 6/8.
Alright, so 16/8 would be 2. And you said 6. Yep. So 2 and 6/8. That's our final answer. Okay. Yeah, it does. Okay. Everybody stand up beside your desk.
Mom, 2.
Okay, and so for 1 minute, because 1 minute is longer than you think, I just want you to move. You can jump up and down, you can walk, you can march, you can do some jumping jacks as long as you don't whack somebody in the face. Okay? Just move. Just get up and move. Walk and play. Just right by your desk. You can stretch.
I'm doing running. Yeah, I am. I was moving my finger.
Keep moving. Keep moving.
I gotta move. I gotta get my finger bones.
No statues.
Your finger bones. Right.
Keep stretching. Keep moving. Keep wiggling.
I thought you said a minute was a long time. Yeah, I thought you said a minute.
Like a burpee?
I thought you said a minute was a long time.
A minute's pretty long, isn't it?
No.
We do a lot in a minute.
We did 34 seconds. 34 seconds.
Alright, have a seat.
The fact that I wasn't even
Okay. Now you've got Miss Charity in second period's always telling us to get blood going to that brain. Sit up. Be tall.
Then we
Yeah,
gotta
just
put our head
movement
down.
helps. Alright, let's do just 1 or 2 more practice problems and then we're ready to move to our problem set. Okay. Get rid of that and that. And we're going to go with 6 and 1/9 minus 4 and 3/9. Okay. Now to solve that. Jumping here with mad. My quick pause tells me I can't take 3 away from 1, so I am going to use mad and get those fractions changed to mixed numbers. Nope, not going to do that. I'm going to change those mixed numbers to improper fractions. Anyway, so what does this mixed number become? Yeah.
It becomes 55 ninths.
55 ninths. Because 9 times 6. And I don't know if y'all realize this. These are ninths. I have 6 whole pieces right here. 6 whole numbers. This is 6 sets of 9 ninths. And I'm really kind of borrowing all of them when I do mad because I'm multiplying 9 times 6. 54 plus 1 more is 55 ninths. Okay? What does the second mixed number turn into? Yeah. 39? Okay. I thought you said 31. So. Okay. That's 36 plus 3 more is 39. And these are ninths. So now we've just got to subtract 39 from 55. Okay. What do you get when you do that subtraction? Charlotte, what do you get? 16. Okay. 16 ninths. And do we leave it like that? Nope. And y'all are getting really good at remembering that. We don't leave it as an improper fraction. We change it to
It's illegal.
It's illegal. Unless the directions ask you for an improper fraction. You know, most of the time you're going to change it back to a mixed number. Yeah. Yeah. 2 sets of 9 ninths would be 18. So you know it's only going to be 1 set. And then how many's left? Did you say 1 and 7 ninths? 1 and 7 ninths is your final answer. That almost sounded like the word wrong.
Yeah, I know. I was trying to say that word, but I actually got it.
All right, let's do one more. Okay. Did you have to do math on this?
No.
What'd you get? You can subtract 1 from 6, looking at the fraction pieces. So I'm going to go the quick way here. I'm going to look at the whole numbers. I can subtract 2 from 5 and get 3. I can subtract 1/10 from 6/10 and get 5/10. Okay. This is a 4th grade answer. Perfectly fine. Looks wonderful. But if I asked you for the 5th grade answer.
3 and 1
Okay. Caleb is so excited to be here. It just bubbled right out.
I didn't even mean to say it. It came out. 3 and 1/2.
3 and 1/2. Just so excited about my. Okay. I do realize we are a tad rusty, but really overall, you guys are just jumping right back in, no problem. Okay.
This ain't hard.
It's not.
It's not hard.
It's just remembering what steps to follow and how to do those steps. It's really not difficult. Okay. All right, let's go ahead and put our whiteboards away, and we will take our quick break, and then we'll come back and do a few more practice problems in our workbook.